Hello and welcome to this homework assignment problem session for Chapter 6. The first problem I'm going to look at is number 6.2, at least when I pulled in the homework assignments. And I'm going to work this problem for you, at least partially, actually totally. So 5 years ago, Logocom made a $5 million investment in a new high temperature material. The product was not well accepted after the first year on the market. However, when it was reintroduced 4 years later, it did sell well during the year. Major research funding to broaden the application has cost $15 million in year 5. Determine the rate of return for these net cash flows in thousands of dollar units. And these are the net cash flows. So in year 0, that was the 5 million expressed in thousands of dollars. So that's minus $5,000. In year 1, they apparently did have a profit of $3 million. And then after that, years 2 and 3, there was no profit. And then in year 4, this was when they the product became accepted by the market. They made $22 million, which is expressed as 22,000 because these are thousands of dollars. And then finally, in year 5, they spent another $15 million on research to broaden the application of the product. So you can see, if we look at years 0 through 5, there's a negative cash flow at time 0, which is common for us. And then there's some positive cash flows, and then there's another negative, which is kind of unusual, but it could happen. So the first thing we're going to do is, because there are 2 sign changes, this is from minus to plus, and then stays the same, then plus to minus, 2 sign changes. We need to check out Nordstrom's criterion, which looks at the cumulative cash flow, which we call S, which is the sum of the cash flows. S sub j actually equals to the sum t equals 0 to j of a sub t. These are the values of a sub t here, okay? So the first, at time 0, S sub 0 is just the a sub 0, okay? It's minus 5,000. At time 1, we add that minus 5,000 to the plus 3,000, and we end up with minus 2,000. And then we add the minus 2,000 to 0, we still end up with minus 2,000, and then again a minus 2,000. And then in year 4, we add the minus 2,000 to the plus 22,000, so we end up with plus 20,000. So now we had a sign change here in SJ, but then we had a minus 15,000, we had a plus 20,000, so that's going to leave us a plus 5,000. So this is this cumulative cash flows, what we call the S sub zeros or S sub j's. And remember, Nordstrom's criterion requires 2 things. One is that S sub 0 be less than 0, and it is. And the other thing is that's only 1 sign change. 1 sign S-I-G-N sign change. And the second item of Nordstrom's criterion is also satisfied. This minus, 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 it changes sign here and it stays the same, so it doesn't change again. So it's one sign change. So this is telling us that this cash flow, because Nordstrom's criterion is met, there's one real positive rate of return, internal rate of return, I star. Okay, so that much we know. Now we just need to set up the equation for the internal rate of return, which says basically the present worth of the cash flow. Don't use this cash flow. The only reason we ever get the cumulative cash flow is to check out Nordstrom's criterion when we have sign changes over here, okay? So we have multiple sign changes. So we're going to now do a rate of return calculation on this. And we're going to basically set up a present worth equals 0 and solve for I star. So that's going to be present worth at some unknown rate I star equals 0. And then we'll have the present worth. Okay, present worth, some known to I star, equals minus 5,000, which is really 5 million because the numbers are in thousands, but that's neither here nor there, plus 3,000 P given F at I star rate for one period. Nothing here to worry about, nothing here. Then you got a plus 22,000. We want to bring that back to the present time. That's 4 years in the future. P given F, I star, and 4. And then finally, we have minus 15,000 at year 5. So I'll put that down here. I ran out of room. Minus 15,000, P given F, I star, and 5. And so now we have to solve this equation. We set it equal to 0, set the equation equal to 0, and solve for I star. Well, you know, what normally I do is do this by trial and error. And for example, I always like to start with this graphic, look at it at present worth at some rate I versus the interest rate I. Now, I always start at 0. I say, okay, what if the interest rate is 0? Actually, then the present worth is this last number right here because it's just the sum of the cash flows. So it would be 5,000, actually 5 million, but we're working in thousands of dollars. And so the next thing I would do if I was solving this by trial and error is I would go ahead and find the I would pick another rate and then find the present worth at that rate. Well, I would go with 10%. So if I do that, if I look for the present worth at 10%, I'm going to get another value. In fact, it won't be much different from this $5,000. So what I'm going to find out is, hey, this thing here is going to extend way out because at 10%, I'm up here somewhere, just below 5,000. It hasn't gone down much. So this thing is going to do something like this. Actually, I went ahead then and used my IRR function in Excel, which is if you put in a cell equal IRR, which finds the internal rate of return of a cash flow, and you tell it which cells that cash flow is in, as long as you make it from 0 to N and fill in all the cells, don't leave any zeros out, for example, in that case. And suppose this were, let's say, column E in my Excel file, and this is row 2 here, 2, 3, 4, 5, 6, 7, then I would put in IRR of the cells E2 through E7. If you do that, your cell value will return 41.03%. So Excel will give me that rate of return, and because of Nordstrom's criterion, we know there's only one real positive rate of return to that cash flow. We got it. That's the end of problem 6.2 on the homework, and I'll go on to the next one now. Problem 6.3 actually comes from a section that I didn't cover in the video lecture or even put into the reading assignment. And because I couldn't take this problem out of the homework assignments in Connect, it works out that if a student has looked at those assignments, then the instructor can no longer remove homework problems. So I would have removed it, but rather than doing that, I'm going to work this problem in detail and essentially show you how to do external rate of return, and you'll also have the answer to the question. So let's go back then and read the question. For the cash flow shown below, there it is, find the external rate of return with the reinvestment rate of 15%. So he has given us a new kind of concept. It's called I sub R, which is the reinvestment rate. And basically, we are going to assume then that any positive cash flows that come out of this particular investment will be reinvested and earn 15% going to the future. So this particular method of external rate of return is going to involve basically setting the future value of the cash flow equal to 0. But let's back up a little bit and see why we're using external rate of return at all. First of all, we don't have to go very far to realize that Nordstrom's criterion for cash flows that have multiple sign changes does not hold in this case, because the first cash flow is not negative. Remember, there were two conditions. The first cash flow has to be negative, and there must only be one sign change to get one real positive internal rate of return. Nordstrom's criterion is not satisfied by this cash flow. So I'm not even going to calculate the cumulative cash flows. In fact, there are 3 sign changes in the cash flow itself. And because of that, there could be as many as 3 real positive rates of return. I don't know how many there are, but because of that, we're not going to look at internal rate of return. We're going to use this other concept called external rate of return. The author also mentions that the external rate of return, ERR, remember ROR was internal rate of return, and ROR, remember, was I star, okay? Well, ERR, external rate of return, is I double prime. I double prime is obtained by the return on invested capital method. So this is a new method of looking at the cash flows. The return on invested capital method involves the following steps. The first step is to move the future value of the cash flows forward one time period at a time using equation 6.5. Okay, so we're going to move the future value of the cash flows forward one period at a time using this cash flow, and I'll show you exactly how we do that in just a minute. Where this K value here, so this is the future value at time t will equal to the future value at time t minus 1 times 1 plus K plus the net cash flow at time t, where K equals I sub r if the future value here is positive and it's equal to I, the unknown value. This is a known value. We were given that. This is an unknown value, okay? If the future value at time t minus 1 is negative. And then the second part of that is to set the future value at time n equal to 0 and solve for the I double prime. So that's basically what we're going to do. I'm going to start it off here where you can see it and do one step, and then I'll take this off and we'll do additional steps, okay? So we're going to start at time 0, so we'll get the future worth at time 1 is equal to, I'm using this equation, the future worth at time 0 times 1 plus K plus the net cash flow at time 1. Okay, so what's the future worth at time 0? It's plus $48,000, and this says that K equals the reinvestment rate I sub r if this is positive. So this is positive, it's plus 48, so this is going to be future worth at time 1 equals 48,000 times 1 plus the I sub r plus the net cash flow at time 1, which is 20,000. Well, I sub r is 15%, so the future worth at time 1 will be equal to 48,000. That was the future worth at time 0 times 1.15 plus 20,000. And if you multiply that out, you're going to get this product here is 55,200 plus 20,000. So the future worth at time 1 will be 75,000. That's the sum of these two and 200. 75,200. So now we're going to use that function to get the future value at time 2. We're going to move this thing forward one period at a time until we get to time n, which is time 4 in this problem, and then we're going to set it equal to 0 and solve for I double prime. So I'm going to show you one more step. We'll take another step forward. And we're going to do that here on this this next page, this blank page. So the future worth at time 2 equals the future worth at time 1 times 1 plus K plus the net cash flow at time 2. And I'm going to put this here so we can see it. The net cash flow at time 2 is 90,000, but we're more concerned right now with the future worth at time 1. So this is going to be future worth at time 2 equals future worth at time 1, which is 75,200. And since that's positive, we use the reinvestment rate for this K value. So this is going to be 1 plus 0.15. That's the reinvestment rate, okay, 1.15. Plus, we're going to add to that now the minus 90,000, which is the time 2 cash flow, minus 90,000. And when we do that multiplication, we're going to get a negative number. We're going to get minus 3,520 for the sum of this and this, okay? So now we're going to go to the third year. The future worth at time 3 equals the future worth at time 2 times 1 plus k plus the net cash flow at time 3. And the future worth at time 2 is negative, minus 3,520. So that means this k value is going to be our external rate of return I double prime. So this is going to be 1 plus I double prime, which is an unknown, plus the cash flow at time 3, which is plus $50,000. Plus 50,000. And when we do this multiplication, we're going to get that the future worth at time 3 is, see, if we multiply this minus 3,520 times 1, we'll get minus 3,520. Let's do that over here. Minus 3,520 times I double prime. I'm sorry. Yes, that will be when we multiply it times I double prime. Minus, when we multiply it times 1, 3,520. And then we'll add the 50,000 plus 50,000. Ran out of space here. But when we add these two, we're going to get 46,480. So the future worth at time 3 will be that sum, 46,480, minus 3,520 times I double prime. And this looks like it will be a positive value, right? Because I double prime is not likely to be such a huge number that this would be negative, right? Because it's, you know, even if it was 100%, this would only be a 1, okay, this value, okay? This is not likely to be a negative number, the sum of these two. So we're going to say future worth at time 4, and remember we're going to set that equal to 0, equals, well, the future worth at time 3 times 1 plus k plus the net cash flow at time 4. Okay, well, the future worth at time 3, we're going to assume that that is a positive number because it certainly looks like it will. 46,480 minus 3,520 times I double prime is the future worth at time 3, and we're going to multiply that times 1 plus k. Well, k would be the reinvestment rate, I sub r, as long as this number's positive, recall. So I'm going to say it's I sub r is 1.15, and then we add the cash flow at time 4, which is minus 52,000 to that, and we will get our, then we set all of this equal to 0 and solve that equation. Well, it turns out that this product of 46,000 times 1.15 is 53,452 and excuse me, and this product of minus 3520 I double prime, times 1.15 is minus $48 times I double prime. And then we have the minus 52,000 out here. And that's still equal to 0. And so now we move the 40,000 to the other side and make it a plus, and we subtract the 52 from the left side from the 452. We'll get 1 452 on the left side. We'll get plus 4048 I double prime on the right hand side, and set that equal to 0. Well, we've already moved this over to the other side. Okay, so we don't need to do that. We just set these two equal to one another, and we solve this for I double prime. I double prime will be equal to 1452 divided by 4048, which turns out to be 0.3587 or 35.87%. So that's the external rate of return method. That's how it's worked, and I've put all the data and all the explanations here, and these notes will be posted online as well. So the next problem we'll work is 6.4. Problem 6.4 says, on the advice of your uncle, you purchased 10 shares of a well-established U.S.-based corporate stock for $20 per share. So you bought 10 shares for $20 a share. After 1 quarter, you received a 25 cents per share dividend. Remember, you own 10 shares. Each quarter for 2 years, at that point, you receive these 25 cent per share dividends. At that point, the stock price had gone down in a short-term recession, so you purchased 10 more shares at $16 per share. Okay, so at the end of 2 years or 8 quarters, remember you're getting a quarterly dividend, which is an A series, so you're going to want to work in quarters. Okay, so that purchase occurs at the end of the 8th quarter, 2 years. The stock continued to pay 25 cents a share on all 20 shares because you bought 10 more, you had 10, now you got 20, and you're getting 25 cents a share dividends, okay? After 3 years, 12 quarters, you decided to sell the stock since it had increased in market value to $23 a share. Make the following assumptions: no commissions for the purchase or sale of the stock, no government taxes on the dividends, and quarterly compounding of the rate of return. What is the effective interest rate per year? Okay, so the first thing I did for you was to set up a cash flow table. And this column here is the quarters, okay? Because I had a cash flow for the first 8 quarters of 10 shares times 25 cents a share. So there are the first 8 dividends there. I also originally, initially had to buy the 10 shares at $20 a share. So that's $200 at time 0. And then at time 8, or at the end of the second year, I bought 10 more shares at $16 a share. So that's minus 160. And then finally, at the end of the third year, I continued to receive dividends during the third year. That's quarter 9, 10, 11, and 12. But I'm receiving the 25-cent dividend on 20 shares now. So I get $5 a share. $5 a quarter. And then I sell the stock, all 20 shares, for $23 a share. And I put the wrong number here. $23 a share times 20 shares is $460. 460. I got used to using big numbers. $460. Okay. Now, the problem, and I'm not going to work the rest of it for you, but the problem is to solve for I quarterly now. So here's your cash flow, and you set the present worth of the cash flow equal to 0. You solve for the internal rate of return, and then you use the effective interest rate formula for the to get I annual. Well, let me set up equation 1 for you. Since I messed up there, I'll do that. The first step, solve for I quarterly. So we'll set the present worth at I star quarterly equal to 0. Well, what do we have here? We have minus $200. That's the present time. Then we have a uniform series of 8 quarters here. We'll account for, so I've accounted for that. I'm going to account for this uniform series of 8 quarters by saying that's $2.50 P given A, I star, and 8. So I've accounted for them now. Then I have a minus $160 here. And that's at time 8. So that's going to be P given, and that's a single payment, I star and 8. Then I have a uniform series in the last part of $5 a share, or $5 per quarter, 5.00. And I want to bring that back for 4 quarters, P given A, I star, and 4. But where's this number now? This number is at the beginning of the 9th quarter. But that's the same as the end of the 8th quarter. So now I have to bring that single amount back, P given F, I star, and 8 quarters. And then finally I have this 400. So I've counted for that now. And then finally I have the plus $460. P given F, I star, and 12 quarters. So when I solve this equation for I quarterly, and you could do it in different ways. You could use Excel, or you can just do it by trial and error. Once you get I quarterly that solves this equation, the second step then is that I annual, the effective annual rate, equals 1 plus the nominal annual, R annual, divided by 4 to the 4th power minus 1. What's R annual? Well, it's going to be 4 times the quarterly rate. And so when you multiply by 4, then divide by 4, you're just going to get equals to 1 plus I star quarterly to the fourth power minus 1. So that'll be how you solve problem 6.4. And I'm going to work one more problem, and we'll do that in just a second. This problem, which was 6.5 when I accessed the homework assignment, is also from section 6.7. So I'm going to work this problem in detail for you, even down to the final answer. Also, I want to point out that the problem is not properly stated. So I crossed this out. He called this external rate of return. And it's not really. I said determine not the external rate of return, but the modified internal rate of return using the MIR method. Okay. Modified internal rate of return method. And then the author goes on to say, so this I crossed out, this I added to the question that I got, okay? So he said determine the external rate of return using the modified internal rate of return method, where the reinvestment rate, I sub R, is 18%, and the borrowing rate, I sub B, is 10%. So if you're using this MIR method, you're going to need two rates given to you, and you're going to solve for something called a modified internal rate of return. Now, we had an internal rate of return we called ROR, and we gave it the symbol I star. The modified internal rate of return is going to be I prime. Remember, the external rate of return was I double prime. Okay, so this is going to be I prime. And then verify your answer with the spreadsheet function. And we can do that also, but let's look at what this method involves. The modified internal rate of return method, okay? There are basically 3 steps. Step 1 is to get the future worth of the positive cash flows at the reinvestment rate. So find the future worth at using the reinvestment rate at time n of the sum, which is the sum of all the positive A sub t's. That's a cash flow at time t. If it's positive, it's taken out to the future. Times 1 plus I sub R. How far do we have to take a cash flow that occurs at time t into the future? Well, n minus t periods. Okay, so we take it at the rate I sub R for n minus t periods. The second step is to take all of the negative cash flows, find the present worth at the borrowing rate, B I sub B, at time 0, will be the sum of the negative cash flows, the A sub t's, brought back to the present time, which would be 1 plus I sub B to the minus t. How many years do we have to bring something at time t back to the present? That many years. And then the third step, once we've got this value and this value, we use equation 6.4 to set the future worth and solve for the modified internal rate of return. So we'll say the future worth of the I sub R, this one here, and n equal to the present worth of at I sub b and 0 times 1 plus I prime to the nth power. So this is going to take that present worth, take it out to the future. Okay, and these were the negative cash flows, present worth of them, but it's going to be as a positive number. So these are both going to be positive numbers, even though these were negative cash flows. So we're actually taking the negative of this, taking the negative of the cash flow, which was a negative number. Okay, so those are the three steps. Let me get the net cash flow. Sometimes it's just called the cash flow, net cash flow, or just cash flow. At time 0, it's minus $6,000 because there is no revenue at time 0. At time 1, you've got a revenue of $25,000 and a cost of $30,000, so that's minus $5,000 netted out. And then at time 2, you got $19,000 minus $7,000, so that's plus $12,000. At time 3, you got $4,000 plus and $4,500 minus, so that's minus $500. And at time 4, you got $28,000 minus $12,000, which is plus $16,000. So there are two positive cash flows for us to work with in step 1. So in step 1, this is the procedure. Step 1, we're going to find the future worth at the reinvestment rate of 18% at time 4 of these two positive cash flows. So that will be $12,000. It's at time 2. I need to bring it forward 2 periods. So it's times 1.18 squared, or second power. Then I'm going to add to that the 16,000, which is at time. It's already at time 4. So those two will be the cumulative, the future value of the positive cash flows at the reinvestment rate. And when you do that calculation, you're going to get $32,709. The second step is to take all your negative cash flows back to the present using the borrowing rate, which in this case is 10%. So step 2 will be find present worth at 10% at t equals 0 of the negative cash flows, and we're going to do the negative of the negatives, so it's going to be minus $6,000. That's at time 0, so I don't have to do anything with it. And then I have minus $5,000. I need to bring it back 1 year, 1.1 to the minus 1. Then I have a minus 500. That's at time 3. I want to bring it back 3 years, 1.1 to the minus 3. And if you do that calculation, you're going to get $10,921. And remember, I changed the sign by putting a negative there. So we have the future worth at 18% of the positive cash flows. We have the present worth at 10%, that's the borrowing rate, of the negative cash flows, but converted to a positive number. And now we set up equation 6.4 from your textbook, which sets the future worth equal to the present worth times 1 plus I prime to the 4th power. So we're going to do that in step 3. We have the future worth, which is 32,709, equal to the present worth of that we got from step 2 of the negative cash flows, but as a positive number, 921, times 1 plus I prime to the 4th power. And now we can solve this equation for I prime. You could do it in a number of different ways, but by this point in time, hopefully you can figure out how to do that. And what I got for the I prime would be equal to 0.3155, or it's not I prime, not I star. I prime is equal to 31.55%. And what I basically did was divide through by 10,921, and then I took that value and took it to the 1/4 power. So I'm basically taking to the 1/4 power both sides of the equation to the 0.25 power, and that leaves you 1 plus I, and then you just subtract 1 from it, and you'll get 0.3155. So that solves this problem 6.5, and I also presented that in detail in the lecture notes for these, and that'll be posted online. And that concludes our homework problem session.